Hi everyone. Today I'm going to start a new session on recurrent neural network. So this is an advanced concept and in the neural network as well as in the natural language processing. Uh, as a human being, right? So we always keep on improving things that we have done earlier. So in the same fashion, uh, there are certain applications where you cannot use the standard mechanisms that we had studied earlier. So we want to see if we can apply a new mechanism to solve certain problem that we're going to be talking about a little later. So this is a very interesting topic that has come up in the recent years. When we try to improve certain things, we make it a little more complex, right? So this one is a bit complex than what we had studied earlier. The mechanisms of learning is going to be a lot more difficult than what we have seen earlier. The way we construct the neural network is very different from what we have done earlier, so on. Okay. So we pay attention to this lecture, also understand a lot of relevant material that are out there in the internet. All right. You definitely have to understand this particular topic if you want to develop applications based on the RNN we call it. Right. So before that, take a little step back and then see what we have done so far, and then get on to the business of understanding a neural network. So right from the beginning, right, we started with the pre-processing. We started with dividing the corpus into words, tokens, or sentences, paragraphs, and so on, depending on what we are looking at. And then we wanted to find out whether it's possible to get the meaning out of the word given the context of words surrounding it. So we use some methods using LSI and then try to find out the word embeddings, which is not just a representative or an index of the word, but it contains some additional information related to the word in terms of its context surrounding words, similar words, and so on. So in this context, the similar is not equal to a synonym. It is equal to a word that could have some neighborhood relationship. All right. So for example, if you say automobile, workshop could be a neighborhood word for the automobile. So the word vector could have some representation of the dealership or workshop along with the automobile. That's what we meant by word embedding. So we were able to get something out of that from the corpus through LSI, and we got a set of word vectors for the vocabulary that we are looking at in a given corpus, right? And then the accuracy in terms of prediction increases. All right. And then we wanted to find out if these learnings can be made possible through another mechanism through neural networks. So we started looking at the perceptron and then started looking at how we can classify words and then how we can really find out a sentiment of a word, by taking a small example, and then try to construct multi-layer perceptrons, and then later converted the multi-layer perceptron into a model where we used a training mechanism to train the network so that the network achieves whatever that we are looking at. Okay. And the parameters which we are looking at are the weights as part of the network. And then we also saw that it's possible to really construct neural networks using different mechanism. We saw Seebaugh model, we saw skip-gram model, and we were able to really construct the word embeddings using those models, right. So now we want to see whether that can be extended so that the next stage in the natural language processing is about understanding a sentence. We saw how a word can be understood and the neighborhood relationship can be captured, and now the next stage is after predicting the next word, we should be able to understand the sentence, and then we should be able to understand the paragraph, we should be able to understand the document and then paraphrase it or summarize that, and then later take a paragraph from one language, translate it to the another, and so on and so forth. Okay. So, these are all the tasks that are still pending in the neural network as far as the class is concerned. So, we will see whether we can move to the next level of understanding a sentence through recurrent neural network. So, which was not possible with the standard model of the neural network. Okay. Okay. So, this is what I am going to be covering in the in this session. Okay. So, I am going to be talking about the recurrent neural network, giving a brief overview of what we have done with respect to the language model, and then we will talk about the word-to-vec model and then see what are the limitations. And then for the next stage of taking the understanding, is standard ANN good enough? If not, what should we do? And we will talk about sequence learning. So, what is sequence learning all about? And then we take a very small example of a recurrent neuron and then explain that, and then try to talk about what is the meaning of unrolling an RNN. Okay. So, in the recurrent neural network, we are going to be talking about the time series. Okay. Earlier in the other neural net world that we spoke about, there is no concept of time. Okay. They are all static networks. So, in this case there is a time involved in this. So, we want to see how words can be input into this network and then how the RNN can be unrolled in the time sequence. We will also look at the character based language model. We have not done that earlier, but we will look at it here, and we look at the standard language model through RNN. And then the most important part is training. Training contains a lot of interesting math. We will do this towards the end of the session, we will not do it in the middle. We will look at the training especially through back propagation through time. So, when you look at the RNN, it is nothing more than a collection of back propagation network. Okay. And then how do you really back propagate through time, since time is involved. So, we need to back propagate the error through time, so that we are able to adjust all the weights to make the neural network or take the neural network to an equilibrium state. What happens when you have a long time series? So, we will talk about exploding and vanishing gradient. What does it mean? When you have a neural net which is unrolled in time, so we will have several layers, right. So, we were talking about taking a sentence as part of the input into the neural network, right. The sentence can be of any size, it is only limited by the time. So, when you have a sentence of about 20 words or 30 words, or you want to process a paragraph of about 200 words, I should be able to input all the words one after the other through the network, so that it learns and then does whatever we are asking it to do, right. When we do the back propagation through time, and when you come from the topmost layer to the bottommost layer, the gradients start diminishing in size, or it start becoming bigger. So, that is when the neural network either explodes or vanishes, the gradient vanishes. And then there is a mechanism, we will just talk about how we can really clip it, so that we can avoid the problem of explosion and vanishing part of the gradient. Okay. So, this is going to be the structure of this lecture. I will talk about this training once we finish the gradient clipping part and so on. All right. Until then, we assume that we are going to be training the neural network, we are going to assume certain mathematical equations as true and move forward. Okay. All right. This is something that you should be very familiar with, right. The first one that you see on the screen is a keyboard that predicts what is going to be the next word. So, what does it do? So, when you start typing the words, or when you start typing the part of the word, it starts showing you some options for you, right. So, you can pick even before you complete your word or a sentence, and it saves a lot of time for you, right. There is a prediction involved in this, and when you want to predict what happens behind the scenes, obviously there is a natural language processing that is running this application, correct. So, in this case, if you look at this, I wish you many, I am sure many of you won't have typed the entire sentence of I wish you many more happy returns of the day. You just keep typing few characters and the prediction appears, you just touch them, so the entire sentence is complete, correct. So, you just go and then play with this and then see how far it takes you, and beyond a point, this particular small NLP application will start repeating or start throwing some random words for you. Okay, so, it will never let you complete sometimes. So, but that is wonderful, even for us on a small device you are able to do this, and there is a small NLP application behind that which is predicting the word that you are going to be typing. The second one, again when you start searching for a particular topic in the Google search box, you see lots of options dropping down, correct. So, in this case when I type deep learning for, so you can see the first one is coming as deep learning for computer vision. So, it looks like lots of folks in the vicinity where I live search for computer vision related topics and deep learning. And then interestingly, deep learning for dummies appears as the second option for you. So, again how do they come up? So, based on what you type, as you type deep and you will see lot of things popping up, right, in the drop down box, and when you type deep learning, again the options are getting reduced and you see certain options being populated, and then when you type for, again you see lots of things. When you start typing computer, you will see certain more options are getting restricted, but you will see still see about 10 or 15 options, or depending on how it is configured, right. So, again there is a natural language processing behind this scene, correct. And then the third one is very interesting, even though I do not like it. This application provides you an option to complete the sentence, not just the words, right. So, in this case, I got a meeting request and then we had done some work and then some attachment was sent to me, and then I am just responding to this mail thinking that okay, I am going to be typing this attachment that this person had sent looks good, maybe we can make few more modifications and so on and so forth. Okay, when I start typing elbow OK, I can see that there is a sentence that is being completed as part of the application, right. So, this is pretty dangerous. That means it is really reading what I am doing, okay, in one way. But if you look at it from the technology perspective, as a technologist, I really love this, right. So, I am able to really complete the sentence without really typing the whole thing. These kinds of filling the data for you is really cool. So, this is another one where the NLP is behind the scenes, right. So, for all these, right, if you look at it, the characters that I am typing, when you are going to be typing the word here, the word size is not limited. It could be a 4-letter word, 5-letter word, or 2-letter or 6-letter word, and so on, right. So, as and when you type, it keeps looking at the characters that you have typed, and then based on what you have typed, that is your context, and it tries to find out the equivalent word that is available in the dictionary and then fills it, correct. So, the size of the input is not limited here, not just 4 words. So, it does not do it just for 4 words, it does for 2 words, or rather 2 characters, 4 character words, 5 character words, and so on and so forth, right. So, the input size is not limited. Even in this case, the input size is not limited. It is not limited to 3 words or 4 words. You start typing the character, it starts appearing, it gives you the right word for you, and then when you complete the first word and then start typing the second word, it start completing your sentence, correct. So, that means the input size is variable here too. Even in this case, the input size is variable. So, can the application that we have developed so far or the techniques that we have looked so far using the neural net solve this problem? This is what we are going to be looking at, all right.